Hi, welcome to the Your Innovation Coach webinar. Today's topic is a 5-step approach to reducing time to market. Of course, time to market is very important to us in new product development. We're always striving to get our products to market faster for a variety of reasons, some of which are listed here. I do think that focusing on time to market does give us a good way to look at the entire NPD process. The problem, I think, in thinking about time to market is that we tend to focus on the wrong things, and I would point out three issues in my opinion that tend to illustrate this point. One is that from a management standpoint, we tend to think sometimes the way to solve this problem is that if project teams just worked harder, then all of the problems would be solved. We would be able to get products to market faster. And that just is not the case. That's a short-sighted approach. It really doesn't get to the root causes of the problem. Secondly, is in my experience, not every project should be accelerated. Sometimes projects just need some time for things to settle out, so to speak. Maybe it's a radical new to the market type of development or a brand new business model. Whatever, there's certainly data out there that suggests that time to market does not always correlate with market success. So you have to be careful and not just haphazardly assume that every project needs to be accelerated. And third, we don't want to accelerate the wrong project. So this discussion assumes that you've got a robust process in place to actually choose the right projects. That's really the essence of portfolio management. We'll talk about that in a future webinar, but for the purposes of this discussion, we're assuming that you actually are picking the right projects, and now the question is, how do you get to market just as quickly as possible? So what I want to lay out to you is what I believe is a better way to think about time to market. It's a 5-step approach. It actually comes from this reference that I saw several years ago. I've incorporated it into my thinking. We'll go through each of these in turn. I'll give you some tools and tips that either are based on my experience or what works in other companies or what I've seen in research and so forth. So we're going to go through each of these in turn, and you start here and you end up here in terms of these steps. There are 3 things that I would point out. First of all is naturally we tend to go to the last step. We want to focus on trying to speed up the process. The point I'm going to make to you today is that there are other things that you need to think about before you get to this step. The second point I would make is that as we go through these 5, you'll notice that some of the things we're going to talk about are at the individual project level, but others are at the system level. And in fact, I would make the case that you probably have more leverage to make the biggest impact on time to market thinking about the system in general rather than at the individual project at the project level. And the third point is that there's good overlap between this topic today and what we talked about last month in terms of overloading resources. So obviously overloading resources impacts time to market in the sense that it bogs down the entire system, as we talked about last in that webinar. And so that is an important connection with the topic we talked about last month, and some of the stuff we're going to talk about today is related to that. Okay, so let's first of all, I want to spend some time first of all on this concept of simplify. In other words, how can you look at individual projects and simplify individual projects to get them to market faster, or thinking about the overall system in general. And there are 5 things we're going to talk about here today. The first being this concept of incremental versus mega projects. This really has to do with how are you defining new projects when you start a development, and are you inadvertently defining a project as a mega project, and is it really necessary? So what is a mega project? Well, I think it stems from human nature in the sense that when we start a development in many organizations, we want to try to pack in everything that anyone has ever asked us for in that development. It's the kitchen sink approach. You know, you want to cover all your bases, so to speak. And that can be a real problem from a time to market standpoint, because those kind of projects tend to be very long duration, which means that the planning horizon is very long, which makes it difficult to plan. Simultaneously, there are changes to the market happening, which all means that the project gets redirected, which means the schedule will slip further. It means the duration is even longer, so it's this vicious cycle. Similarly, the scope is very large because we try to pack in everything that anyone has ever asked us for, which means the risk is higher, there's higher investment, means there's more planning at the management level. Again, a lot of redirection of the project, more features get added, so scope creep comes into play, the scope expands. Again, this is just the type of project that just never seems to end. And if you've ever managed this type of a project, you know what I'm talking about. And really, projects exist on some continuum from a incremental type of development all the way to a mega project. Incremental development tends to be lower complexity, which means the risk is lower. You can get to market faster. Mega projects tend to be very complex. The schedule risk is higher. They tend to take longer to get to market. So you need to think about that in terms of how are you defining projects, and are you inadvertently defining them as mega projects, which does impact time to market. And there is a different way to approach it. One reason why you use a platform strategy is to break up a large development into logical chunks. So by, rather than trying to hit the home run at the very beginning, it might be better to split it up into incremental development, come out with a generation 1 product that meets some basic customer needs so you can get to market faster and capture those sales, and then you come out with a next generation and a final generation. So, there's a challenge in doing this, of course, in the sense that it takes more planning, takes more resources sometimes to think this through. We tend to want to jump right into development, whereas this requires you to think through a little bit more about what you're doing. It also means that you have to understand customer needs more, and that can also be a challenge, especially in smaller to mid-sized organizations. And that really gets to the heart of industry segmentation, understanding the market segments, understanding where your biggest bang for your buck is in terms of development, and then using, say, a platform strategy to develop an initial generation to attack certain markets, and then incrementally improve that product over time in order to address other markets. So that's really the essence of industry segmentation and a platform strategy. Okay, so the second thing in terms of simplification really has to do with thinking about your project portfolio in general, and whether it might be beneficial to actually reduce the number of projects that you're working on. And this is a tough sell in many organizations in order to make the case that actually reducing the number of projects that you're working on will actually help you speed time to market. And it's the concept here of what's called the law of lead time. Too many projects for the resources is the number one problem every company faces. I mean, it comes out in survey after survey in terms of this problem, and we talked about it last month as well in terms of overloading of resources. And I think it's, I want to introduce you to this concept of the cumulative frontier. I think it's human nature that we want to just keep adding projects into the portfolio. And one way you can look at the projects in your portfolio is to plot the data in this way. And it's based on taking a project and calculating what's called the NP index, or the new product index, which is some measure of the gain of the development, in this case net present value, divided by the cost, let's say in the amount of resources that it's going to take in order to get that product to market. So you can calculate this NP index for every project in your portfolio, and then sort those projects from high, which are very efficient projects, to low. And you'll find typically in most organizations you'll see this type of a graph. And the bottom line is, if you really critically look at this, you'll quickly realize that a high percent of the value of the projects that you're working on can probably be completed with a fraction of the resources. So, you know, we tend to want to pack in a lot of projects in the portfolio and end up overloading of our resources. Now, it's not to say that you would never do a project up here. You know, you may need to do a project that, you know, contributes a small amount of value relative to the resources, maybe because of regulatory requirements or something like that. But the question becomes, do you really need to do that? And would it be beneficial to cut some of these projects out of the portfolio? And that's the question. And that really gets to this concept of the law of lead time, or what's called Little's law. Little was a mathematician that proved this relationship back in the early 60s. This is the generalized version of Little's law, but is applied to product development and thinking about it as a process. Little's law says that the average overall project lead time is equal to the total number of projects in your process divided by the average completion rate. So to illustrate this in an example, we're going to make the assumption that you've got some metrics that show that you can do basically 5 projects per month given the resource pool that you have to work with. So if you take that and looking at Little's law, it's basically a linear relationship. So you've got lead time to complete the projects in months plotted against the number of projects in the process based on that formula, and based on 5 projects per month as the average completion rate. So if you plot that, you'll see that if you have 60 projects in process, so to speak, on average it's going to take about 12 months to complete those projects. If you cut those number of projects in your process from 60 down to, say, 40, you'll reduce that average completion rate to 8 months. So you can gain a lot of time to market by simply reducing the number of projects in your process. You know, this is a very difficult thing to convince, especially management in organizations, that by reducing the total number of projects in your process, you can actually reduce time to market. It seems counterintuitive. Our natural inclination is to want to put more into the process because we think the more we put in, that will motivate people. It'll get things out the other end, and it just doesn't work that way. And so this is an example that proves that point. I think I would throw out there might be some caveats to this argument. I think that this relationship is probably true where you've got a lot of projects in the process and the project lead times are relatively short, and there's not huge variation from, you know, on the low end to the high end in terms of time or project, you know, the length of the projects. So I mean, I think if you're working on very few projects, this relationship might not be exactly appropriate, but it does make the point that the more projects you put into the process, the more things will bog down. So it, again, kind of ties into the discussion that we had last month. So the real important point here is that you really need to think about your overall portfolio, and if you can cut the number of projects in your portfolio in terms of in process, then you will pick up time to market given that same resource pool. The third point I want to make is this concept of technology versus product development. I think in many cases we mix those things up. They're not the same thing. Technology development is not the same thing as product development. I think this is also a big challenge for smaller organizations because in many cases our developments include some level of technology development. And if technology development is part of your project, then that makes it more difficult to manage those projects because it's typically the technology development aspect that is the biggest risk, especially at the beginning of the project. And so you have to be wary of that. If you're combining technology development with your product development, then there is a downside in terms of time to market. You have to be careful with that. Again, I'll go back to the slide before. A platform strategy, really assumes that you understand what you want to develop, but you break out the technology building blocks. You understand what's going to be required over the longer term in order to get to market. So by thinking about your development in a platform sense, and thinking about maybe you need to develop some technology parallel to your first generation, so to speak, that will go into maybe later generations, it's a way to separate this concept of product development versus technology development. Again, this becomes more challenging in smaller to mid-sized organizations because of resource requirements. Being able to separate out this technology apart from the projects can be a challenge in terms of resourcing that development that's outside of outside of an actual product project itself. But you would be really better served if you could do that. Again, it takes some thinking through of what's going to be required in future generations of the project or product in order to get it to market. There are other things that you can do in terms of simplification, reducing the number of vendors, simplifying documentation. This is especially true for manufacturing companies. Sometimes in my experience when I was in industry, I wish I could sell the beautiful multi-page assembly drawings that we would do. But the fact is we would do those, they would go into files and never really be looked at. So you could consider in a manufacturing context to do a simple one-page exploded view and then use Word documents and pictures in order to develop assembly procedures in manufacturing. So that's just an illustration of all kinds of things that you can do from a simplification standpoint relative to documentation to try to eliminate that and simplify the entire process. Okay, so again, the first focus is simplification, both at the project level and at the system level, particularly in terms of the number of projects in your process and really thinking that through critically. That's probably the biggest point, and then how you're defining projects and whether you're inadvertently defining mega projects. I would say those are the two big things that I want you to take away from this discussion about simplification. Second now is once you've simplified, now let's focus on how can you eliminate steps in the process. And again, there are multiple things I want to talk about. The first is inertia. And this really has to do with our processes and our defined written processes within our organizations. If your development process is an ISO process, then it's probably a documented process with certain steps, checklists, and so forth. And my experience sometimes is that as organizations grow larger, processes that are put in place are never revisited. A perfect example is if your new product development process doesn't really delineate between a minor project and a major project, you might be forcing your project team to go through a lot of extra steps in the development for a minor project that are just not necessary. So you need to beware of inertia within your organization and always critically examine those processes to make sure that you're not tying the hands of the project managers to make them go through steps that are really not necessary. The second point I want to make in terms of eliminating steps is the role of system architecture. And this is a very important topic. This slide illustrates what I'm talking about, at least from an electronic component standpoint, but it's true of any real system, mechanical or electronic or electromechanical or whatever, in terms of breaking it apart into its subsystems and how that happens. And by a smart system architecture, you might find that you can break out a development and outsource this as an OEM to buy it off the shelf, so to speak, an OEM development. And that might eliminate steps and save you a lot of time in the development, especially if it's a non-critical technology to you. So smart system architecture will allow you to break things apart in a way that might allow you to offload a particular module or subsystem to another an OEM type of situation. System architecture is something that I would make the case ought to be elevated in your thinking. I think in many cases, in my experience, it's relegated to an engineering decision, and it really should be viewed as a strategic decision for the project. System architecture, which is defined. I mean, there are many aspects of system architecture. It has to do with system boundaries. What's the boundary? What's in the system and what's not in the system? How modular is the system? Where are functions going to be located within the subsystems? Interfaces between the systems. Can you use standardized interfaces, or do you have to develop your own interface? And how do you define those to allow things to work better within the development? And maintaining some kind of flexibility, in terms of locking in decisions on the architecture. The architecture is something that gets done at the beginning of the project, and I make the case that they're strategic decisions, because once the architecture gets put in place, later in the project it's very difficult to change without really impacting time to market. So that's why I make the case that you really need to elevate your thinking about system architecture and bring it to the forefront in terms of a strategic decision within the project. Of course, there are other things that you can do in terms of eliminating steps. Some of those are pointed out here in terms of relying on vendors and collaborators. I mentioned that in the case of system architecture, reducing part count, using customers to do some testing. I'm sure in your organization you can find other ways that you can eliminate steps. So that's the second approach here is you simplify, you eliminate as many steps. Now the third thing we're going to talk about is how can you do things in parallel. So parallel processing. And again, I have multiple things I want to point out. And I start back at architecture. Again, by smart architecture, you can break things into chunks that allow development to happen in parallel. So that's a critical decision within the architectural design of the system, is how can you break things apart to maybe allow things to happen in parallel? And by defining the interfaces very well, then that allows you to do that. Sometimes system architecture, in my experience, is also done in concert with your resources, because it may some of your resources that are available to do different things, it might make sense to think about that in the sense of architecture, whereas by how you break things apart may allow, rather than having one person has to do two things, that it leverages the resources that you do so that things can be done in parallel. The second point I want to make in terms of parallel processing is your development process itself. Sometimes, our phase development systems are kind of illustrated in a linear fashion. We go through phase 1, we go through a gate, we enter phase 2, we go through a gate, we enter phase 3. And that's how phase gate development processes are typically illustrated. We're not going to talk about phase gate today. That's, again, a topic for another webinar, but the point is they're in many cases approached from a linear fashion, but you really can't think of them in that way. You really have to run your development not as a linear process, but how can you find ways to do things in parallel? Phases are going to naturally overlap. They have to overlap, and if you're going to speed up your time to market, you have to think of these in terms of what can you do in parallel. A great example, especially in a manufacturing company, is the engineering versus the manufacturing processes. Let's say phase 2 is an engineering phase and phase 3 is a manufacturing phase. There really should be overlap. This should not be the case where R&D throws it over the wall, so to speak, to manufacturing. Manufacturing should be heavily involved in this engineering phase, and that's where you can pick up a lot of time in terms of parallel processing. It might also refer to risk buys. In other words, you may decide in the engineering phase to purchase some parts for manufacturing, knowing full well that maybe certain things have not been locked down in terms of the design, or things haven't been fully tested. But you may, in that case, be trading time for money. So by taking risk buys of certain things, then you might be able to do things in parallel and speed time to market. So think about your development process, and don't think of it as a linear process, but think of it as how can you leverage and do things more in parallel. And this gets back actually to what I was mentioning before, and that is how you document the process and giving the project manager flexibility in doing these types of things. And also the project manager project management skills are very important in understanding what you can do in parallel and coming to the business with, say, for instance, making a decision on risk buys in order to trade time for money. And in many cases, when we're talking about time to market, that's really what it comes down to, trading time for money. It was true when we talked about the system architecture in terms of using OEM modules. They probably will be more expensive, but you can speed time to market. So much of what we do in time to market is trading time for money. Of course, there are other things that we can do in terms of parallel processing. I mentioned this, project management skills. A skilled project manager will help figure out what can be done in parallel. Customer involvement, sufficient number of prototypes. I've seen that happen in manufacturing companies where you shortchange the number of prototypes because you think it's going to cost less money, but it actually costs more in the long run. So again, you're trading time for money in that scenario. So don't short circuit or shortchange your development by reducing the number of prototypes. And those are decisions that get made early in the project. Okay, so we've simplified as much as possible at the project and the system level. We've eliminated as many steps. We've figured out ways that we can do things more in parallel. Now let's look at, okay, with what's left, how can we eliminate delays in the process? And there are three things that I want to point out here. First is decision making. And this really gets to our decision making processes within new product development. And in particular, the role of senior management and their engagement in the process. I spent a lot of time with clients on these decision-making processes. It should be part of your overall thinking. How do you make sure that you have robust decision-making? And it can have a big impact on time to market. And just to illustrate the point, in many projects that I've been associated with, invariably through a multi-year development especially, there are many occasions when there's a fork in the road, so to speak, and a decision has to be made at the management level. The project team needs a decision made, and sometimes senior management in particular view their role in new product development as a secondary task, and so they delay meeting with the team in order to make a decision. So, a decision might get to be delayed for maybe as little as 2 weeks, but if you take the number of decisions that have to be made and you add up all the time in the process that gets wasted because of poor decision-making process, that can add up to a lot of time. And in many cases, it's linear time that you can't get back. So it's very important that there is robust decision-making, and especially on a management level, that there's good engagement and that decisions get made as quickly as possible in order to eliminate delays in the process. The second is this concept of the law of innovation variation. And that's a mouthful for sure, if you say that 3 times quickly. It goes back to something that we talked about last webinar on the overloading of resources. It's a similar type of concept. It really has to do with the tasks within the projects and the fact that in new product development, the tasks have a lot of variation. You never can figure out exactly how long those tasks are going to take. So this plot illustrates the point. It looks at the time consumed per task plotted against the percent utilization of your resources. And this is this illustration assumes that it takes your development engineering folks a 5-day per design task, let's say, on average. Our natural tendency in organizations is that we want to load our resources at 100%. I mentioned this in the webinar last month, that from an efficiency standpoint, we believe that all of our resources have to be used at 100% efficiency, which means that we load them 100%. But there's a big downside to that, and especially in your critical resources that are on the critical path. The fact is that the more tasks or the higher they're utilized, the longer tasks take, because it gets back to this concept of multitasking and the switching costs as we go from task to task. So there's certainly an inflection point somewhere on this curve, and of course every business, this curve will look different in every business, but the point is that at some level of utilization, probably somewhere in the 65 to 70 to 80% range, once you get above that, you pay a big penalty in terms of the average time per task that it takes to complete those tasks. So you have to think very critically about loading your resources at 100%. Now, this is not true, as I mentioned last webinar, of every resource. There are certain resources that the switching costs are lower and that they can be loaded at a higher percent. But I think that, and this is the resource for this concept that illustrates these 7 imperatives for thinking about the law of innovation variation, and it really gets to, first of all, identifying who your critical resources are in the project. And those are typically folks that have really high-risk tasks that are on the critical path. So that's the first step. And that might not be everybody in the project team, right? It'll be just the ones that fall into this category. And the recommendation here is to load those critical resources no more than 65%. And it goes back to that plot that we showed on the previous curve. Gives you the best chance of accommodating this task variation that invariably is part of new product development. Third is to focus on the upstream suppliers for those critical resources. So, they need to make sure that the things that they need in order to keep moving forward are there, because they're on the critical path typically. So the project manager really needs to think about the upstream suppliers to those resources and put into place some type of feedback loop to understand what the cues are for those critical resources. And then fifth is, as much as possible, if your critical resources are doing more routine tasks, how can you offload some of those routine tasks to other personnel? If you recall back in the webinar last month when we talked about resource allocation, this kind of gets to that comment where every resource has certain amount of background noise, so to speak, in terms of generalized support to the organization. But that can suck up a lot of time. And so is there a way to offload, say, support the manufacturing or support the sales, so to speak, of your critical resources in order to free them up and make sure that you can accommodate this task variation? You can reduce task variation by reusing building blocks within the development. This gets back to this platform strategy and reusing technology across the different platforms. And then last is prevent multitasking of your critical resources, especially. We talked about that. The more that you multitask, the more switching costs there are, and the more problems that you incorporate into the system. So a good way to think about variation in your tasks and how to make sure that you don't overload the resources and what it does to time to market. Kind of related to this is the concept of flow. So this, I'm taking a page out of the manufacturing processes where we talk about flow through a system. And that's a lot of the basis of the lean manufacturing technologies, is how do you increase flow through the system by breaking things down into smaller chunks. But in addition, you look at things like functional bottlenecks and how that affects flow through the system. This is illustrated in a process standpoint, but you could think of it just like product development, where these are projects. You got multiple projects, and are there functional bottlenecks? It might be a person, it might be a critical resource that it just seems like, you know, is always the bottleneck in the system. Or it might be key CAD resources, for instance. In an organization that I was involved in, it was electrical CAD resource that always was a bottleneck. And so the point is, you can attack these bottlenecks that affect all the projects and have great leverage to increase the flow through the system and reduce those queues that we talked about previously. Okay, so once you've simplified, eliminated steps, figured out where you can do things in parallel, and then attacked where there are delays in the system, once you've done those, now we can finally come to actually speeding up the process. And there are 4 things that I want to talk about here. The first is product definition. So product definition, the point I want to make here is that sometimes going slow will actually help you go fast when it comes to new product development. And product definition is something that we do at the beginning of the development, but sometimes we like to rush headlong into the development rather than really thinking through how we're going, you know, what it is that we're going to develop. You know, and this is a tongue-in-cheek way to illustrate that if you were relying on hallway conversations to define new products, you are subject to this concept, and that is that hallway conversations lead to a great variation in what people think the product needs to be. You know, this might be the customer's vision, but every part of the organization thinks of it differently. And that's a recipe for a lot of problems as the project unfolds. You will not be able to speed up products to market if you're not doing a really good job up front in terms of making sure that you're setting the right expectations, that everybody is on the same page in terms of what you're actually developing. The point is, I like to make, is that product definition also is not a singular event. It's not that you're going to sit down one day and you're going to, in most cases anyway, I mean, it depends on the complexity of the project, but in many cases it's not a singular event. You define a project, you evaluate it through the organization with the various stakeholders. You know, I like to always have one person that's responsible for driving that definition. It doesn't mean they make all the decisions, but they have to drive the process, and then it gets evaluated with all the stakeholders, and it's an iterative process. You know, you might be able to sit down and define it in one day and get everybody's agreement, but in a lot of cases it's an iterative process, and it might take days or months even for some types of projects to fully define it. The other thing I'll point out is this whole project definition process sits between what I would call the portfolio process and your phase gate development type process. You know, in the portfolio process, you know, and there's back and forth here. You might learn something that kicks the project back here. It has to be reevaluated in light of other opportunities that you've got. So that's why it's part of the portfolio process. And you have to do some basic definition even in this stage in order to try to pick which projects you're going to develop. So that's why it's part of the portfolio process, and as you develop the definition, it might get kicked back in here and reprioritized. Same thing is true on the phase gate. I mean, once you kind of start a project definition is really the beginning part of the phase. But you, again, might learn something as you go through the development that kicks it all the way back into the portfolio process, or at least back into the definition phase. So project definition kind of sits within the portfolio process and the beginning part of the phase gate process. So it's not a singular event, it's a process that you go through in order to really formally defining a new product. This is some data that comes out of NASA, in the sense that there is quantitative data that suggests that the more time that you spend on definition, maybe the better off you're going to be. And this was on projects, and what they're plotting here is program cost overrun, which you could relate to project, you know, schedule slip and so forth. plotted against the total percent cost that you spend on requirements relative to the entire cost of the project. And so you'll see here that there's this relationship that you can actually, in this case, by increasing the spending or the time that you spend on the definitions from, say, 5% of the total cost to 15% of the total cost, you can pick up pretty significant reduction in time to market. So that's the point, that there is a sweet spot here in terms of, if you shortchange the time that you spend on definition, there is a price to pay, and it has to do with down the road in terms of scope creep and other problems that come in because you're not really fully defined. Whereas if you spend a little more time up front, you're less likely to have problems down the road. That's what this data proves. Of course, there's a sweet spot. Obviously, you can't continually to work on the definition because then you'll never get to market. But the point is that you might want to spend more time on definition, spend more time, go slow to go fast type of thing, and do yourself a lot of good when it comes to speeding up the development process. Okay, the second thing I want to talk about is the project manager. Project management skills, again, like I made the case with architectural decisions, need to be elevated. Project management skills are obviously very important. A skilled project manager will really know what the levers are to pull in order to speed up the project. A project manager that's used to incremental projects, suddenly you're starting to do new to the world type of projects, you have to understand that there's going to be a learning curve with your project management skills. A second point I would make is that it's dangerous in many situations that your project manager is also a contributing person on the project, or more importantly, if they're on the critical path of the project. So you have to be very careful with your project managers. You've got to elevate this in terms of a skill set, and you've got to make sure that you're not overloading that project manager with both project management roles and content development. This relates to the project management skills, and that is making sure that you choose the right project management tools for the project. And this is a really important graph or plot that helps make this point. So on the bottom here on this matrix are sources of uncertainty in your project. And it starts with task variation. This is the lowest level of uncertainty, so to speak, in your project. And this really relates to the fact that as you build a schedule that, let's say you know all the tasks in the schedule, and it's a matter now of projecting how long this task is going to take, and that feeds into the next task, and so on and so forth. So let's say you've got a 2-week task in order to wait for a part that comes in from a vendor. Well, that's not really 2 weeks. It's 2 weeks plus or minus some normal variation. It might take a week, it might take 3 weeks. So that's normal task variation, and it's incorporated in your entire schedule. So there's a variation in every task. So that's the least onerous type of uncertainty in your project. Second type of uncertainty is foreseeable events. These are things that you can anticipate, and you have a way to mitigate that risk. So for instance, you might have a part that you're going to use, but you're not sure if it's going to work in testing. So you're going to have a backup plan in terms of a different part. If that risk comes up, then you know what you're going to do in order to mitigate that risk. Final type of risk are unknown unknowns. These are things that you don't know. This is the most difficult type of uncertainty that we face in projects. Every project in some degree has some unknown unknowns, but if it dominates your project, then it's a very difficult project to manage. So these are your sources of uncertainty. On the y-axis here is project complexity, from low complexity to high complexity. Complexity relates to the number of elements in your system, let's say a new product development, a new project, new product, and how it interacts with one another. So you might have a system that has a lot of parts, but if they don't really interact with one another, then it's not necessarily a high complexity system. But if you've got a lot of parts that interact with one another, let's say it's a lot of electromechanical subsystems and embedded software that touches every subsystem, that can be a very complex system. So based on the complexity of the project and where your sources of uncertainty will drive the type of project management tools that you use. So if you're down here in this quadrant, your typical Microsoft project and Gantt charts work very well, and most project managers are very familiar with that. But up here in this quadrant where you're faced with a lot of unknown unknowns and maybe a large degree of complexity, doing a Microsoft Gantt chart is a waste of time. Here you're really going to be focusing on the lean methodologies, the concept of iterate and learn, or parallel trials in order to reduce risk. So you're really not trying to manage the project with a Gantt chart up here. You're really focusing on what don't you know and how can you learn it as quickly as possible. So this really gets to some of the lean project management tools. We're going to talk about that in a future webinar. I want to make a point here that if you're down here, a good way to approach developing a schedule if you are building a Gantt chart is to use this concept of critical chain. It's a little bit different way of building a project schedule. Typically when we build project schedules, Gantt charts, we go to every contributor, we ask them how long a task is going to take, we put those tasks together, we figure out what the critical chain is, and then we can set an end date or the critical path is, and we can set an end date to the project. Problem is that every task in this scenario has safety built into it, because what happens with somebody estimating this task? Let's say you as a project manager go to a contributor and ask how long this design task is going to take, and they will think about it and they'll say, let's say 4 weeks. In the back of their mind, what they're really thinking is, well, if I have everything I need and I don't get interrupted, I can probably do this task in 2 weeks. But the fact is I can't count on that. So I'm going to tell the project manager 4 weeks just to be safe. So every task in the project schedule includes safety. But what happens is the project starts to unfold. This person does not start the task on time, maybe because they think they have a lot of safety built in and they know they've got some buffer. So they wait a couple weeks to start it. Then they start that task, and then Murphy's Law kicks in, and there's a problem. And now the task goes over. And then that feeds into this task, and this task goes over, and on and on and on until the odds are that, in my experience, you build a schedule like this, that's why the risk of going over schedule is a lot higher in my experience than actually coming in. You really have no way of pulling in the project schedule, because every human nature being what it is, everybody delays starting their task, and then it just builds on itself, and the project becomes late. So a different way to approach that is to build a schedule in a different way. You go to each person and you ask them for how long it's going to take their task, that it's a 50-50 chance that it will come in on time. In other words, 50% of the time you will go over that schedule, and 50% of the time you'll come under that schedule. And then you build the schedule, you identify the critical path, and then what you do is you, based on a simple formula, you build in buffers that are 50% of the task length. So this project buffer is 50% of all the critical path tasks, and then any feeding buffers are 50% of those feeding tasks. So what you're doing is you're pulling out the safety from each individual task, and you're pulling it into a overall buffer. I would contend that in this case you have a case to actually pull the project in, versus here you're subject to also what's called Parkinson's law, which means that as soon as the schedule gets set here, you will fill up that time. Of course, as I mentioned, I think the odds are more that you're going to go over here, over schedule here, but here you have a chance of pulling it in. Now it's a challenge to implement this type of technique. You have to educate everybody on the benefits of these buffers. It's very important. This gets back to overloading of the resources and what we talked about, the law of innovation variation and so forth. You really have to focus especially on the critical path, those folks starting on time. And what happens if they're multitasking and the fact that they can't start their tasks on time. You don't punish late delivery, but you want to try to reward early delivery. Now, I'm not saying that you have to do financial rewards. It may be as simple as telling somebody to take their spouse out to dinner or something like that. So you know that 50% of the time they're going to come in late, but you're trying to reward early delivery. And really the only thing that matters from a project management standpoint is getting that task done on time. That's all that matters, and then the buffers will take care of the rest. And then basically the project manager manages that buffer. So it's a different way of approaching building a Gantt chart if you're down in that lower left quadrant, but it's a powerful way. The Scrum technique or the Agile techniques is similar to basically it's a lean project management tool. Again, I think we're going to have some future webinars that will focus on these lean tools. Scrum and Agile and software development is one of those types of lean methodologies. It really is built around short iterations in order to get fast feedback and to learn as quickly as possible. And that's what you have to do if you're up in that right top quadrant, is how do you learn as quickly as possible. And so we can apply some of these concepts up into that right-hand quadrant in terms of how we manage the project. I have some other project management tools that I work with. This is actually a lean product development, online lean product development management tool. And then I also have a tool that I work with that is used for medical device manufacturers. Okay, and then the last one I want to deal with in terms of speeding up is the concept of front loading of resources. And this illustrates the typical phase gate development process. We'll touch on this in a future webinar. But in a typical phase gate process, it really is built around the fact that you minimize investment at the beginning of the project. And as the project unfolds, investment goes up, which means the number of people in the project goes up. Problem is what happens in many cases, it's down at the back end of the project where things might be going astray, and management's natural tendency is to add more resources at the back end. And if you've ever run a project, you know that in many cases that actually hurts the project more than it helps. So a different way to approach it is, especially on higher risk projects, is to front load resources. There is some research that says that if you put more resources at the beginning, which makes sense in order to reduce the risk, especially in a higher risk project, you're less likely to run into problems at the back end. So front loading of resources is a way to speed up the project, and then you won't hopefully suffer at the back end in terms of trying to add more resources in order to take care of some problems that come up. Okay, so hopefully I've given you some better ideas, and rather than jumping strictly to speeding up or focusing simply on the project teams working harder and faster, I hope that I gave you some things to think about that you need to do before you focus on speeding up the development process. And you'll notice none of what we talked about even in speeding up related to getting people to work 14-hour days. Nothing in this presentation related to that, though that, in my experience, is many cases how senior management especially thinks about time to market. I would point out that in my experience there are probably three big factors that influence time to market. One is this concept of overloading resources, what we talked about of the law of innovation variation, the drive to load our resources at 100% in new product development is a real danger, and the raw number of projects in our process. I mean, this is a very important point, and in my experience is a big problem with time to market. Scope creep and project definition. Doing project definition well, going slow to go fast, making sure that by good project definition that you reduce the chance of scope creep. Making sure that you don't define mega projects inadvertently, which leads to long time to market. So all these topics associated with project definition and scope creep are, in my experience, very important. And third is this concept of mixing up technology versus product development. Especially in smaller to mid-sized organizations, that's a big problem, and you need to think about that in terms of how you're running your overall process. You'll notice that, many things that we talked about, as I mentioned at the outset, have to do with the entire system, not just at the individual project level. And if there's one thing that I hope for you to take away from this presentation is that you really need to address time to market at the NPD system level. That's where you have the greatest investment. You need to think of new product development as a complicated system, and you have much more leverage at the system level to affect time to market than you do at the individual project level. Okay, I want to thank you for attending the webinar today. Happy to answer any questions. If you want to get in contact with me, here's my contact information, and have a great day.